I'm in my balloon making era. But I'm not talking about bunnies. I'm André Isaacs, and this is Molecular Structures. Before we begin, electrons are negatively charged and are usually found in pairs. Like charges repel, so each pair will want to be as far apart from each other as possible. I'm going to use a balloon to represent one pair of electrons. The balloon is perfect because it simulates how much space the electron pair occupies. Now watch how everything falls into place and the unique shapes develop. We have the valence shell electron pair repulsion, or VSEPR theory, right at our fingertips. Each balloon will represent a group of electrons. This could be a pair of electrons in a single bond, two pairs of electrons in a double bond, three pairs in a triple bond, or a lone unbonded pair. Let's start simple. Two electron groups around a central atom, something like carbon dioxide, CO2. The electron groups will most likely be on opposite sides of the central atom, as far apart as possible. Let's tie these two balloons together to imitate the two electron groups. You can see that they are at 180 degrees to each other. This is a straight line, so we call this a linear molecule. Now, let's move to three electron groups by adding a third balloon. The system now looks like a flat triangle, which we call trigonal planar. The electron groups are at 120 degrees from each other. We can represent this as a big molecular model as well. Here is a real example, boron trihydride. What's 3 plus 1? 4 balloons. You'd think they would adopt a flat square, but after tossing this around, we get something more three-dimensional. This shape is called tetrahedral. The electron groups are at about 109 degree angles from each other, and we can show this as a model. I like to think of it as a tripod, the one that I use to make my TikTok dances around. Or you could visualize it like a person taking a step with their arms outstretched. Let's see if we can add a fifth balloon. This is like a trigonal planar shape called equatorial, with an electron group above and below called axial. If I take the model, you can see that there are two different angles in the structure, one of 120 degrees within the trigonal planar and 90 degrees between the equatorial and the axial positions. You think we can add a sixth? Let's try. It worked. This is an octahedron. Here's the model. All the angles are 90 degrees. So don't worry about balloon bunnies. But balloons explaining VSEPR theory? How cool is that? And there you have it.